Hello and welcome to Edisathi. We'll be doing part 3 of geometry and we'll be covering the topic of quadrilaterals in it. Quadrilateral. Quadrilateral is a four-sided figure that has four interior angles. Or if I go by the definition, I would say four lines in a plane of which no three are either parallel or collinear forms a quadrilateral. In general, what I need to remember is quadrilateral has four sides, four interior angles and four vertices. And this is how a general quadrilateral looks like. It has four sides, four interior angles and four vertices. Now if I join the opposite side, I get diagonals. So AC and BD are the two diagonals for this quadrilateral. A quadrilateral has two diagonals. The next thing that I need to know is that the measure of interior angle adds up to 360 degree. So even if you remember the formula for polygon that we have done, the sum of all the interior angles is n minus 2 into 180. Here n is 4, so 2 into 180 gives me an answer of 360. The sum of all the interior angles of any quadrilateral would add up to 360 degrees. The perimeter of this would be given as the sum of its side. So AB plus BC plus CD plus DA, AD would give me the perimeter of this quadrilateral. To find out the area of this quadrilateral, I can split it into two triangles by taking a diagonal, and if I look at it, if I take AC as the diagonal, the area of this will be half into AC into H1, which is the height drawn from the opposite vertex. For the second, it will be half into AC into H2. So combining the things, I'll get half into AC into H1 plus H2. Now there are special kind of quadrilaterals that I need to understand. We'll be starting up with square, followed by rectangle, parallelogram, rhombus, and we'll end it up with trapezium. So let's understand a square first. A square looks like what you have on your screen. The certain properties of square, and those properties are all the sides are equal. All the sides of square are equal and opposite sides are parallel. So this side would be parallel to this. This side would be parallel to this. So opposite sides are equal and opposite sides are parallel. That is the first thing. All the interior angles are 90 degree. Since all the sides are equal, all the angles would be equal and the sum of all the angles is 360 degrees. So all the angles turns out to be 90 degrees. Both the diagonals AC and BD are also equal in length, and the length of each diagonal is equal to a root 2. You can apply Pythagoras Theorem here. A square plus A square, that is 2A square, root of it will be equal to AC. So it is A root 2, which is the diagonal of a square. The perimeter of a square is given by 4A. 4 times the side length is the perimeter. And the area of square is given as A square. So if you remember the formula, the general formula is base into height. Base is also A and height is also A. So I'll get the formula A square. The next type of quadrilateral that we'll be discussing is a rectangle. A rectangle has 4 sides, but only opposite sides are equal and parallel. So if I look at the figure given to me on the screen, I would look at AD is parallel to BC and AD is equal to BC. Similarly, AB is parallel to DC and AB is equal to DC. So only opposite pair of sides are equal and parallel, but the adjacent sides AB and BC are not equal, which is the case of square. In square, all the 4 sides are equal, but in case of rectangle, only opposite sides are equal. All the interior angles of a rectangle are equal and are equal to 90 degrees. This is similar to the case of square. All the interior angles are equal and they are equal to 90 degree. Even the diagonals AC and BD are equal in length, and their length is given by Pythagoras Theorem, which is under root of L square plus B square. So AC square will be equal to AD square plus DC square. So just putting the values, this is L square plus B square. So the value of AC would be under root of L square plus B square. The perimeter of rectangle is given by a sum of all the sides, so it will be L plus B plus L plus B. Taking 2 common, I'll get twice of L plus B as the perimeter of a rectangle. Area of rectangle is given by length into width. So length into width would give you the area of a rectangle. Let's look at an example related to rectangle. The figure below is composed of 2 rectangles. If AB is equal to 8, so this AB which is given to me is 8, and AC is equal to 9, what is the perimeter of this figure? Perimeter means sum of all the sides. So I'll add up 8 plus 9 plus this side plus this side plus this side and this side. That would give me the perimeter of this figure. Now, I don't know what is, if I look at the first rectangle, I don't know what is the width of this rectangle. Right. So, I need to figure out a way in which I can find the perimeter. Just do a little bit of construction. So, this side will be equal to this side. I'm drawing another rectangle over here. I'm just extending these sides. This side will be equal to this side. So instead of finding this side and this side lengths and adding them up, I can find out the length of this side and add them up. Now, I know this is 8, I know this is 9. This entire would also be a rectangle because I have made the lines parallel would be equal to 8, and this will be again another side of a rectangle whose side will be equal to 9. So instead of finding out this and this, I will just find out this and add it to all the other sides to give me my answer. So my answer will be twice of 9 plus 8. That gives me an answer of 34. So 34 is the correct answer for perimeter of the figure that was given to you. Moving ahead, we'll look at the third type of quadrilateral, which is a parallelogram. A parallelogram looks like this. It is referred to as a quadrilateral in which opposite sides are parallel and equal. So BC and AD are equal and parallel. Similarly, AB is parallel to DC and equal to DC. But the difference between a parallelogram and a rectangle is vertex angles are not 90 degree in case of parallelogram. In case of rectangles, all the vertex angles are equal and they are equal to 90 degree, which is not the case in a parallelogram. In case of parallelogram, the only thing that I need to keep in mind is opposite sides are congruent and opposite angles are equal. So opposite sides are parallel, opposite angles are equal, and the sum of adjacent angles is equal to 180 degrees. So if I talk about this angle BAD and angle ABC, the sum of these two angles would be equal to 180 degree. Any two adjacent angles would add up to 180 degrees and opposite angles are equal. So if I talk about this angle that I have, the one BAD and BCD, opposite angles are equal and adjacent angles add up to 180 degree. Talking about the diagonals are not equal in length. The diagonals of parallelogram are not equal. One is a longer diagonal, another one is a shorter diagonal. However, the two diagonals bisect each other at the midpoint. So diagonals bisect each other, but they are not equal in length. The perimeter would be given by twice of L plus B. So it is L plus B plus L plus B. 2 times L plus B is the perimeter of a parallelogram. Looking at the area, I would say area is given by base into height. So if I talk about base is AD, and if I talk about height is BL that I have. I'll just mark, this was L, BL. AD into BL, which is the height, would give you the area of parallelogram. Splitting up into two triangles and adding up the area would also give me my answer. The two triangles that you will split up would be congruent triangles. So they'll have equal area. So what I can do is I can find out the area of one triangle, multiply it with 2 to get you your answer. So area of triangle ABC, if I look here, would be AC will be the base and H dash will be the height. So half into AC into H dash. Half and 2 will get cancelled out to give you your answer of AC, which is the diagonal, into BH, which is the height from the opposite vertex. So I'll just mark this H. You can also call it as H dash. Another way you can write down the area of a parallelogram is LB. So that means if you don't know the height, you can convert the height into the other side using this formula. So it will be L into B into sine of the angle between them. So L into B into sine of angle A. This is very important formula that we have, and it has wide applications. So L into B into sine A is another way I can find out the area of a parallelogram. Now let's talk about the fourth type, which is a rhombus. And a rhombus looks like this. Rhombus, all sides are equal and opposite sides are parallel. So it is similar to a square till now. All the sides are equal in length and opposite sides are parallel. But the vertex angles are not 90 degrees. So that is the thing that separates it from a square. The vertex angles are not 90 degrees. However, opposite angles are equal. So this B will be equal to D and angle A will be equal to angle C. And the sum of adjacent angles is 180 degrees. Similar to the case of parallelogram, opposite angles are equal, sum of adjacent angles 180, but none of the vertex angle is equal to 90 degrees. The two diagonals that I can have, diagonals are also not equal in length. So similar to a case of parallelogram, rhombus can be assumed as a mixture of square and a parallelogram. The diagonals are not equal, but the diagonals bisect each other at 90 degrees. This is very important. The diagonals bisect each other at 90 degrees. The perimeter of a rhombus would be given as 4a, 4 times one side, and area will be given as base into height. So if I know base multiplied with height, h, would give me the area. I can also do the other thing, which is half into length of the first diagonal into length of the second diagonal. Both the diagonals are perpendicular to each other. So the area of rhombus would be half into D1 into D2. Let's move on to the next type, which is a trapezoid. A quadrilateral in which two opposite sides are parallel is known as a trapezoid. So this is what it looks like. Only a pair of opposite sides is parallel. The other pair, which is here, is AB and CD, is not parallel. Neither AD and BC are equal. It's only about parallel, it's not about being equal. So if I look at the two sides which are parallel and the other two sides are non-parallel. So if I talk about the length of the side AD would be equal to A, which is the length of BC, plus x1 plus x2. This is the height that I have drawn. And if I look at this triangle AB, this triangle, C1 square will be equal to x1 square plus h square. Similarly, in this triangle, C2 square will be equal to x2 square plus h2. Using this, I can find out the unknowns that I have in the question. Another thing that I need to keep in mind is the sum of adjacent angles is 180. Whenever there is a pair of lines which are parallel to each other, the sum of adjacent angles would always be equal to 180 degrees. To find out the length of the diagonals AC and BD, I can again apply Pythagoras Theorem. So AC square will be equal to this base, which will be A plus x1 square plus h square. Similarly, BD will be equal to A plus x2 whole square plus h square. The diagonals are not equal that I have in case of trapezoid. Only if x1 and x2 are equal. Such type of trapezium is known as isosceles trapezium. If x1 and x2 are equal, or I should say c1 and c2 are equal, then only the length of the diagonal AC and BD will become equal. The perimeter of trapezoid is given by sum of all the sides, which is A plus B plus C1 plus C2. It should not be x1 and x2. Sorry, there's a typo mistake. It should be C1 and C2. So it should be A plus B plus C1 plus C2 as the perimeter. And area is given by half into sum of parallel sides into height. This area has been derived by breaking it into two triangles and adding up the area of the two triangles. So it is half into sum of parallel sides into height. That will give me the area of a trapezoid. Let's look at some of the examples. In a parallelogram ABCD, given below AD is 12. So if this side is 12, this side will also be 12. And I know these two sides are parallel to each other. So I know this angle and this angle will be equal, and this angle and this angle will be equal. Now what is given to you is, if the area of ABE, this triangle ABE is what I am talking about, is 3/8 the area of parallelogram ABCD, then EC is. Now whenever you have questions related to areas, you need to know what is the perpendicular height. So if I draw for this triangle, the perpendicular height, it could be drawn inside or outside. If I draw it for, let me call this as H. And if I draw it for the triangle, the perpendicular height will be outside the triangle, again H. So if I just apply the formula ABE, ABE, the area is half into base. The base will be BE into height. Height will be H. Note that height of both the triangle and the parallelogram would be same. This area is 3/8 the area of parallelogram. Area of parallelogram is given by base into height. So if you look here, H will get cancelled out. I can just cancel it out with 4. 4 into 3, the value of BE comes out to be 9 units. So AC, I'm left with 3. So EC is 3 units. Let's look at another example. In the figure given below, equilateral triangle BEG is inscribed in a square ACDF. The area of the square is 16. Find the perimeter of the shaded region. So area of the square is A square, which is equal to 16. So that means the side of the square comes out to be 4. So this side is 4, this side is 4. Now if you look at it, BE and CD are parallel and between the same set of parallel lines. So the length of BE also becomes 4. So that means this also becomes 4 and this also becomes 4 because it is given to you that it's an equilateral triangle. Now, if I am inscribing an equilateral triangle, that is only possible if G is symmetrically placed between E and F. The length of AF is 4, so the length of AG would be 2 and the length of GL would also be 2. Now, applying Pythagoras Theorem in this, I would get 4 square is equal to 2 square plus AP square. So, it will be 16 minus 4 square root, that will give me the length of AB. So it is 12 square root, I can write it as 2 root 3. So the perimeter would be sum of all the sides, 2 plus 4, which is 6 plus 2 root 3, giving me option number D as my answer. Let's look at another example. In the figure given below, BC is equal to 8 and CD is equal to 4 root 2, and angle BCD is 3 times angle CDA. What is the area of parallelogram ABCD? Now in case of parallelogram, I know that the opposite pair of sides are equal and parallel. So this is what I know, and I know that the sum of adjacent angles is 180 degrees. And it is given to me in the question that angle BCD is 3 times angle CDA. So if I add them and put it equal to 180 degree, I'll get the measure of angle ADC. ADC comes out to be 45 degrees. Now to find out the area of parallelogram, I will use the formula AD into DC into sine of the angle between them. This is the formula for area of parallelogram. So which is 8 into 4 root 2 into sine of 45 degree, sine of 45 degree. So if I just calculate the things, sine of 45 is 1 by root 2, I'll get my answer as 32. So 32 is the area of this parallelogram. Another example, the figure below represents a rectangular garden with a walkway around it. The garden is 18 feet long. It's a rectangular garden. So I need to understand that the opposite pair of sides will be equal and parallel. The walkway uniformly 3 feet wide and its edges meets at right angle. What is the area of the walkway? So if you look here, this is 3 and this is also 3. This side is 3, this side is 3. So if you look at, this will be like a bigger rectangle with side length equals to 24. And here it will again be 3 and 3. So this will be 18. If I have to find the area of walkway, one formula that you can apply is area of bigger rectangle minus area of smaller rectangle. So bigger minus smaller would give you the area of walkway. Area of rectangle is length into width and area of smaller will again be length into width. This will be the area of walkway. I can take 18 common, it will be 24 into 12. So if I just do it, it will be 18 into 12. That will be my answer for the area of walkway, which is 216 unit square. If the unit here is feet, so this will be feet square. Okay. So the next thing that we'll be looking at is comparing all the 4 that we have just discussed in the same slide. Parallelogram, rectangle, rhombus and square. All sides are equal for rhombus, for square, but only opposite sides are equal for parallelogram and rectangle. Adjacent sides are not equal for parallelogram and rectangle. However, in all of them, opposite sides are parallel. Okay, opposite sides are equal in all of them, but adjacent sides are not equal in case of parallelogram and rectangle. Vertex angles are 90 degree in case of rectangle and square. In case of parallelogram and rhombus, vertex angles are not 90 degree. Diagonals are equal in case of again rectangle and square, and they are not equal but they bisect each other in all the 4 cases. They do bisect each other in all the 4 cases, and in case of rhombus and square, they bisect each other at 90. Not in the case of parallelogram and rectangle. The diagonals bisect the vertex angles again in case of rhombus and square only. They do not bisect the vertex angles in case of parallelogram and rectangle. The diagonals form 4 triangles of equal area in all the 4 cases. So in all the 4 cases, if I know the area of one triangle, I can multiply it with 2 or 4 depending upon which kind of triangle I have taken to get to the area of the complete figure. Thank you so much for watching the video. I hope you have understood the concept of quadrilaterals. I request you to please like us and subscribe us at our YouTube channel to get more videos on related topics. Have a nice day.